Welcome to the session of HCF, highest common factor. What exactly we mean by highest common factor, we'll find out. First, we'll look at some of the points like what are odd numbers, even numbers, prime numbers and composite numbers. Odd numbers are 1, 3, 5. That means they are not divisible by 2. Any number which is not divisible by 2 and is a positive number, it's an odd number. Here even numbers. Even numbers are multiples of 2 and 2 itself. 2, 4, 6. They are all multiples of 2. And here prime numbers. Prime numbers are one which do not have any common factor. Which do not have any factor beside themselves and 1. Like 5 has factors 1 and 5. 7 has factors 1 and 7 only. They do not have any other factor. And composite numbers are the ones which have more than 2 factors. And this is what we are going to deal with today in HCF, highest common factor. We'll deal with composite numbers like 20, 45, suppose 60. These are the numbers which have more than 2 factors and they are called composite numbers. Before finding out the highest common factor between two numbers, we'll learn how to do the factorization. That means how to find out the factors. Suppose the number is 20. I write 20 here and then the first factor, the first smallest number that is divisible by 20 other than 1 is 2. So 2 tens are, then again 2, here 5 and then 5, 1. So these are the factors of 20. 2 and 5. Let me start with an example. Suppose we have two numbers, 24 and 18. First we find out the factors of 24. 2 is the smallest number which is divisible by 24 other than 1. So we have to find out the prime factors. And 2 again, it gives me 6, 2 and 3. So these are the factors of 24. Similarly, we find out the factors of 18. 2 nines are, 3 threes are, and then 3 and 1. These are the factors of 24 and 18. We write them together like 2 into 2 into 2 into 3. These are the factors for 24 and here are the factors for 18. Now what we do is we make a pair of the similar factors. Like this is the pair. Again we are getting a pair of 2. So we are getting two pairs, a pair of 2 and a pair of 3. So this is my highest common factor. When I multiply these pairs, I get as 6. This is the highest common factor between 24 and 18. That means 6 is the number which is divisible even by 24 as well as by 18. So this is the highest common factor. We find out like this by finding out the factors of the numbers given and then making a pair. Like these are the common factors, 2 and 2. 3 doesn't have a pair among these. So when we make a pair and then multiply one each, we take one from each pair and then multiply them and we get 6. So 6 is the HCF of 24 and 18. Let's see another example. We have seen the example of 18 and 24. Now let's find out the HCF of 30 and 25. Once again, we have to find out the factors of 30 and 25 separately. So 2 15s are, then 3 5s are, and 5 1s are. These are the factors for 30. Similarly, we find out the factors for 25. 25 is divisible only by 5. So we get these factors 5, 5 and 1. We write the factors one below the other, 2 into 3 into 5. There is no need to write a 1. And then 25, that means 5 into 5. Again what we do is, we find out the similar factor and then make a pair out of them. This is one pair that I am getting. There is no other pair. Similar factor means from the first number and the second number, any common factor. So this is the only common factor. I write it as 5. So this 5 means it is the highest common factor among 30 and 25. So this is HCF of 30 and 25. We see another example here. 33 and 42. Once again, we are finding out the factors for 33. So it is divisible by 3. 3 11s are 33. 11 is, we know that it is a prime number. So there are no other factors except the number itself and 1. Here 42. So we find out the factors for 42. 221. Then it is divisible by 3. 7 again is a prime number. 7 is a prime number, so it doesn't have factors other than 7 and 1. We write the factors here, 3 into 11. As I said, we can leave this 1. 1 is of no value here because it is getting multiplied by 1 and the value remains same. 2 into 3 into 7. Once again, we find out the common factor among these. We make a pair of it. So this is the pair that I am getting, 3. No other pair I am getting. Here is 11, here 7 and 2. There is no other pair that I am getting. So the highest common factor of 33 and 42 will be 3. So this is how we find out highest common factor of two numbers. Now we will have a look at the highest common factor with 3 numbers. When I have 3 numbers in hand, how do I find the highest common factor? I have 3 numbers in hand now. Earlier we had seen the highest common factor of 2 numbers. Now we have 3 numbers. The pattern will remain just the same. We find out the factors for 27. 3 9s are 27. 3 and then 3. Then again 3 is a prime number. So there are no other factors for 3. 36. It's divisible by 2 to 18. Then again it follows the same pattern. 3 and then 3 once again. This is how we find out the factors of 36. And then comes 45. 45 is divisible by 3. 3 5s are, and then 5 once again, and then this. So these are the factors for 45, 27 and 36. Let's write them together in a line. 3 into 3 into 3 is 27. 36 has factors 2 into 2 and 3 twice. Then comes the 45. Factors of 45 are 3 into 3 into 5. Now what we have to do, earlier we had made a pair out of these two. Now all 3, if they make a pair, then only it will be the highest common factor. Let's see, 3 is there in every. All the numbers, 3 has a factor. 3 here and 3 here. They make a pair. So we write 3. Now we find out some other pair. 1 more 3 is there. Here also 3 and here also 3. So these 3 are also making a pair, and this is included in this pair. So once again we write 3 because all the factors have to be available in all the numbers, not only in 2 or not only in 1. They have to be available in all. So this 3 and this 3 again combine to make a factor. Now we see, are there any other pairs left? No. So this is 9. 9 is the highest common factor of 27, 36 and 45. You can check it out also. Divide this 27 by 9, you get 3. It is divisible. 36 is also divisible by 9 and 45 is also divisible by 9. So that's a check also. Because when you find out the HCF, you can check it also whether that HCF is divisible by all these 3 numbers or not. That means the answer is correct. We have another example here. We have 3 numbers, 28, 56 and 44. Now let's see how to find the HCF. 28 has factors starting from 2. 2 14s are, 2 7s are, and now we come to a prime number, that is 7. So there are no other factors. In 56, we start with 2, we get 28, and then you can follow these same steps. 2, 14, then again it goes by 2, 7, and then one more 7. This is how we get the factors of 56. Now comes 44. 44 is again an even number, so divisible by 2. Once again it is divisible by 2. Now we get a prime number, that's 11. And there are no further factors of 11. Now we write these factors here in a straight line so that it becomes easy to make pairs. 56 is again 2 into 2 into 2 into 7. See, 56 is a multiple of 28. So we just get an extra 2 here. Nothing beside that. 2 into 2 into 11. These are the factors of 44. Now we try to make a pair. Straight away we are getting a pair here. 2. And again a pair of 2 we are getting here. Now, is there any other pair which is common? See, 7 is common to these two, but not here. So, we are not getting a pair here. And here also 2 is not there in this. So, 2 into 2. That means 4 is the highest common factor among 28, 56 and 44. There is nothing like here all three are combining together to make 1, 2. Then here also the factor, as I said, should be available in all the three numbers. This way we can find out the HCF of 4 numbers, 5 numbers, but this turns out to be a tedious process because we have to write, now the numbers are smaller. If the numbers are bigger, we have to find out the factors first and then find out the common factors. That's a tedious job. So we do prime factorization method. That will be dealing in the next part. Hope you are liking all our videos. So, send in your suggestions and queries in the comment box, share the videos with your friends and press the bell icon for the latest information on all the videos of Maths and English. And don't forget to subscribe the channel Idea Infinity.